what I'm going to talk about is, well, as it was said, I'm Miguel Ángel Torres Gobea. I'm going to talk about practical uses for open source audio fingerprinting and Asterisk and AI on Asterisk. Well, about me and my work, I'm a computer systems engineer. I studied at the National Polytechnic Institute of Mexico. I'm a sysadmin senior. I'm the leader of VoIP and CDI applications at Price Travel Holdings. Also, I'm a professor at the University of Quintana Roo. I lecture about Unix operating systems, and also I give selected topics of VoIP. So, about my work, my full-time work is at Price Travel Holdings. We think we are a technological company that sells customer travel experiences. Well, and the numbers are, we are a company of 2,000 employees. We have 16 physical PBX installations. We manage 3 MPLS or clear channel between Mexico and Colombia. We have 4 contact centers in Mexico and Colombia. We have 25 branch locations at Mexico and Colombia. We manage 1,400 physical extensions. We handle like 40,000 and 60,000 calls per day. And we can handle 1,000 maximum inbound, outbound concurrent calls through the PSTN. And well, one goal that I want to have ending this year is that all our VoIP platforms and computer telephony applications will be open source. We work some applications in-house, and we try to open source them also. So, a long time ago, in an Astricon far, far away, the last Astricon, I'm going to talk about what I talk about the last Astricon. It's a 5-minute presentation before the real presentation. We had a problem. Houston, we have a problem. We have lack of insight. We have to rely on the telco's company service that will be 100% available. We were relying on that blindly. We have to rely on customer and help desk reports to know that something was going wrong. And we have poor batch alert scripts to alert us something was going wrong. And we have to use CLI for debug the PBX on failures. We have non-existent monitoring platforms. That was a mess. So this was a big problem, and it had direct consequences because we have no inbound outbound calls on carrier failures. We have no alert or advice on system degradation, internal or external failures. We have reduced capacity to sell on contact centers. We have lack of insight about infrastructure. So I have been working at Price Travel for 5 years. And looking as a retrospective, I consider this as Project Insight, because the last 3 years we have been working on a lot of things to make this happen. What we wanted to do is to have automatic, active, and rich monitoring. So the phase 1, as I was talking the last Astricon, was using monitoring, network monitoring software, open source and private. And we developed some integrations with Asterisk for Datadog and the Sangoma Vega models. They are not easy to have data about them be through SNMP. So we developed some hacks with Python, and we access all that data that we want. And we have a screen, some monitors telling us what's going on with the voice service infrastructure. The phase 2 was rich monitoring. We were using ELK infrastructure and Last Alert to have real-time log analysis and custom-based alerts. We also have multiple notification services support. We have notifications through Slack, through Telegram, through WhatsApp, SMS, and through calls. This was phase 2. And then we have, at the last year, phase 3. We have a lot of problems with telecommunication companies, providers, and we have to monitor their service because their service fails in the outer of your voice infrastructure, and you receive error reports that the toll-free forwarding numbers are not falling through the DIDs. So we developed a tool to detect telco failures, do some automation of IVR validations, and use audio fingerprinting for this tool. So we call it Aloha. Aloha, when you call to someone, you expect a hi, aloha. And also my girlfriend used to say hi to me, well, with aloha, aloha, aloha. So I call this Aloha. So this tool is open source. I have released on GitHub if you want to use it. It validates all your numbers. It dials the number. It records the number, the code, and then that record is compared to some audio fingerprinting database that you know that the audios are correct. And if there is a successful test, it will tell you that the test is correct. But if it's not, it's going to alert you, Telegram, Slack, and whatever you want to be alerted. So I'm going to release the version 2, I hope, at the end of December of this year. It will integrate a lot of things, LD, AP, login, and some more things that I've been working on. So the phases achievements of the last year were use and create monitoring tools, use rich monitoring and perform automated actions, and automate simple tasks to solve problems. This was good for us. We were, well, it's something that I can sleep in peace because I know that the alerts are not going just only to be sent to me. I have a team of 3 people that also monitors all the voice service infrastructure. And we have a lot of other people that integrates our sysadmin team, and they are also checking all these alerts. And if something happens, like an extension of a director goes down, the people of, for example, in Colombia at Cali, can get the alert and can go and check the phone, the extension phone. It sounds well, not important, but imagine your director of sales is going to have a meeting in the morning, and he gets to the office and he has no phone extension. That's something worrying. Also, with the IVR Aloha, the problems that we were having were that, for example, 2 weeks ago, all the toll-free forwarding numbers, at least for Cancun, as I know, they were down for 2 hours. And the Aloha service notified us, so we contacted the provider, and they said that the problem was national. So we have no toll-free forwarding numbers for our company on that provider, but we could monitor it and don't be dialing manually the numbers. It goes and automatically dials the numbers. So for me, that was like all the things that I could do at Price Travel. But then this year we have well, at this present time, I'm going to talk in another Astricon about something I call the Phase 4. This Phase 4 is, as I said, a new kind of problems. This new kind of problems is like this year at Mexico, we have something that you may have heard in the news. We have the Mexican general elections, and this was a really problem, at least at Mexico, because we're facing a new kind of problems that, yeah, we have these problems in the past, but we didn't have to take solutions or work on a solution for this. We're having an increasing of calls, of political calls at supplies to our contact centers and to some corporate users. So imagine the director of IT says, Miguel, why I'm having these calls through my extension is annoying. Can you please block the number? And he goes another again, because at Mexico, what they did is they have not just only one ID for a campaign. They have multiple IDs, and it's the same recording. So we also realized that we have have no solutions for calls from debt collection agencies, credit cards, and more. Also for fraud, scam, and extortion calls. That's a national problem. There's a big issue with this, and I hope that the government do something about this. Well, in general terms, they are robocallers. So what we were trying to do is to work on a solution. The solution was blacklist databases, as everyone does. Everyone says, well, if you don't want a number, blacklist, and there's no problem, right? So the solution, the first solution that we proposed was using public blacklist calls databases, also provide some automated blacklist IVR, and provide blacklist web portals to the users. So we did a little web login database portal that it just only has a PHP that only saves the number, the description, and it goes to the, as if you are using free PBX, you can use the blacklist feature that puts on the, I'm sorry, which was, is SQLite database into the Asterisk, and it blacklists the number. If this is not a dangerous demo, really not dangerous demo. What I am doing here is just putting a number, 1, 2, 3, 4, 5, 6, blah, blah, blah. I have here an R, new blocked. So I save it and says now it's blocked, and if I go to my server and check asterisk.rx, show grep blacklist, I have my new number blocked there. It's an easy solution. But, well, the advantages of this is blocks easily numbers. There's no complex technical knowledge required, and there's no cost investment. It's low cost. You only have to program a developer, or even not a developer. You can do it by yourself. So the disadvantages is that it has to be manually updated by users. If there's no entry about the users, you are not going to have an updated, you are going to have outdated databases. And also you are relying on third parties to keep it working. You can download a public blacklist database, but that database also is going to have false positives, and you rely on them to have that working very well. So we needed to work on another solution, and that was the version 2 of this finding a solution. So we went to automating blacklist process solution, and as we were using this technology already, we were able to use audio fingerprinting technology for this. Feed audio fingerprinting databases with known audios and detect and block undesired calls. So what we use is something that uses Aloha, is its core for audio fingerprinting technology. We use a Python model that is called Dejavu. Does anyone knows Shazam? Yeah? You know how does it works. You put something, you put the application to listen, and it will tell you the song name. So what it uses is make an audio fingerprinting of the sound or the audio, and it gives some points so you can identify that audio with others. You can compare that. So, and this is open source. The Dejavu comparison script that I'm going to run right now is just only we call the Dejavu library. We make some modules importing, and we only provide the file name that we want to check against our database that we have already populated, and it will tell us something. So let's go to another dangerous demo. Audio fingerprinting technology with detection calls. So what I'm going to put on the system is, sorry that screen that wasn't, I'm going to try to find this recording. Sorry, my bad.
Ricardo Anaya, candidato presidencial del Frente, está en segundo lugar en las encuestas y es el único que le puede ganar a López Obrador.
That's an audio that we want to find. I have already fingerprinted that audio. So if I want to just only add some audios, I'm going to add to my folder audios, and I'm going to make spammer block Dejavu, and it will take all the audios and it will try to fingerprint that audios and store the data on the database. And I'm going to try to search for this specific audio or other audio that I have is anuncio político audio on the system. I'm going to check if today is having something. So I'm running this interface, and it goes to the recording. We have a VoIP monitoring recording interface, and it will go through all the recordings that have 10 seconds or to 60 seconds of duration, and it will try to check and compare all the audios that it has recorded for this day. If it finds, well, the day is, I think that is Tuesday. If it finds something, it will tell us which caller ID we have to block. By this moment, it says that all these recordings that he analyzed and processes, there were no results. So I'm going to try with a day that I know that it has something. So we're going to go to the date of July 2008, the 24, and well, the Dejavu config is loaded, and here you have a number. You have a winner. The script tells us that we have to block this caller ID because it found this recording with this confidence that it means how many points were matching the recording, and we can also get the recording and analyze it just to be sure that it's the recording. Let's go here.
Llamada entrante en 3, 2, 1. Ricardo Anaya, candidato presidencial del Frente, está en segundo lugar en las encuestas y es el único que le puede ganar a López Obrador. Si usted sí sabía esta información...
Yep, that's okay. So, the advantages of audio fingerprinting technologies, we can identify multiple caller IDs associated to a specific campaign ad or raw caller. So we can make automatic updates to the Blacklist database and avoid our users to update the Blacklist database. But the disadvantages, yeah. There's a margin of error with audio fingerprinting comparison. Sometimes it gives you false positives. And you sometimes, well, the bad thing about this is that you have to manually feed back the audio fingerprinting database with known audios. So the administrator has to manually update the audio fingerprintings, and that's really bad. So at the end of the day, you need to keep updated your audio fingerprinting databases, and that's something that we didn't want to do because we want to automate the whole process. So we have to work on a solution again. So the final solution that we came up with is automate blacklist process with deep speech to text. Speech to text. So the solution was using open source solutions for speech to text technology. Somebody has told me why you don't use Google, Amazon, all the stuff that is already there. Well, because let's make some calculations. We have a cloud speech cost provider that for 15 seconds, it charges me $0.006. So the average IM calls per day is like 300 minutes. That means that it's 18,000 seconds. The cost of the day for the IM is $7.2. At that point, it doesn't seem pretty bad, right? But we have 400 IMs, and we want to monitor all the 30 days of the month. So the cost increases exponentially. So, well, we use a technology that is called DeepSpeech from Mozilla. And we use this speech-to-text technology on recordings and get keywords. So we can detect calls with specific keywords and update blacklist databases automatically. So I'm I'm going to talk about Mozilla DeepSpeech technology. This is not a ad, but that's something that if you have, does anyone know what's machine learning and how it works? Okay, 1, 2, 3. This is going to be a crash course about machine learning. Okay, what is it? Machine learning is the way you tell the computer how to identify some certain aspects of real life. For example, in this example, we tell the computer how to identify numbers. For artificial intelligence, you have to develop some complicated algorithms to detect numbers, letters, and if the number or letter changes, you have to write again that code. So what machine learning tells and will help us is that you use only one piece of code algorithm to learn, to make the machine learn what does a number means, what does a letter means, and differentiate between all the variants that you could write, for example, a 4, a 3, or an 8. So why we chose it? Is the state-of-the-art alternative to proprietary solutions. We want to make a state-of-the-art alternative to proprietary solutions. This works with an algorithm that is based on a Baidu research paper, and also is an offline solution, so you have no latency problems. Low latency solution keeps users and clients' privacy. We are PCI compliant, and if we at least store some credit card information we don't want to share with anyone else, not in the cloud. So also we have a lot of user data recorded. We have like 1 year of recordings at Colombia, and we have 8 months of recordings at Mexico. That's a lot of data. We have like 40 terabytes of recordings. So it also is an end-to-end machine learning approach. We have a, that was I put it wrong there. Scaling and quality, it optimizes while you keep the computer training. So we have a lot of data. We have a lot of recordings. That's what machine learning needs. You have only the recordings and the transcripts to make it better. So some deep speech-to-text technologies doesn't work well with variation of Spanish. We have Colombian Spanish, Spanish from España, we have Spanish from Mexico. At Mexico, we have Spanish from, well, Mérida, from Guadalajara, from Monterrey. Everyone speaks a different word for the same meaning. So we want to make something that will learn all about these variations. So how does it work? It uses neural networks. Does anyone know what is a neural network? Yeah, it will seem complicated, but it is not. It is just only math. It's each node that you see there. You have 3 layers or n quantity of layers to process all this information and make the computer learn. So you call them layers. And then you have per each layer some nodes. That's why it's based on neural networks. Each node is just only a calculation, a function that gives us a mathematical value. And you keep processing all this information so you can find an approach of what you want that the machine knows what are you telling. But how does the machine knows if you are only processing forward? Well, you have something that is the cost of calculation, and with that cost, you can tell the computer you're wrong. Go back and make your homework again. So it will go back and it'll try to make some calculations to get the best result of what you're trying to learn. So how does it work? Well, we have a lot of recordings. We have to manually transcribe all these recordings. We need at least for a full working demo like 70,000, 100,000 recordings, like 5 seconds or 20 seconds, and the respective transcriptions. So we feed it to the DeepSpeech engine, and it creates 3 datasets. We have the trained dataset, the dev dataset, and the test dataset. The trained dataset is all the stuff that you want the computer to learn, The test is something is going to validate against too, and the test is just only for double authentication. So, well, how to use DeepSpeech? DeepSpeech is easy to use. I have on this computer installed DeepSpeech project, but for training you need an GPU, at least an NVIDIA GPU, because you are using TensorFlow. DeepSpeech is based on TensorFlow. So you only install Python 3, and that's a requisite, Python 3.5, and you only do pip install DeepSpeech. You get the model. If you want to practice it with English, you can download the pre-trained models, and just only you have to run this command. DeepSpeech models, the output graph is how the calculations are being processed or have been processed with the DeepSpeech technology. The alphabet, you have to tell the computer which letters are the language letters, the alphabet. The LM binary and the tree are the language models. You download a book or a big text, so it can understand the language that you are trying to train. And it will generate these files. One is the binary for optimize, how the computer is going to try to analyze these audios. And the tree is just only for references. And you are going to have you are going to ask that it gives you the transcription of your specific audio. How to use DeepSpeech? Well, I have this little script that it will, in a demo, we will try to, in English models, try to transcribe this in a recording call that is, you have heard it before. You always know this.
I am sorry, that's not a valid extension. Please try again.
So
I am sorry,
we are going to try to transcribe that audio. But how to train the DeepSpeech engine? Well, this is something really slow. As I said, you need computational power, but GPUs, because it's mathematical functions. So you clone the repository of DeepSpeech. You have to use, you have to get installed GitLFS. You use your virtual environment in Python. You enter into that virtual environment. You install DeepSpeech. You install TensorFlow. You install some requirements that are already there. You download a big data set of corpus to make some to make the models that you need for your to make the binaries and the language models for your model, and also you create your alphabet and all your model and tries. This is I am telling this very easily, but this is really hard work to do all that. So at the end of the day, you are going to call DeepSpeech script on Python, or you can use Node.js. There are a lot of bindings for that. And you tell it which are your train sets, your depth sets, your test sets. The train and depth sets, I'm going to go here. Sorry about that. I'm going to go, yeah. Oops. Okay. For the training. Sorry. This is the content of a train set. My bad. Wrong commands. Yep, there it is. You have the WAP file name. It has to be WAP. You have the file size of the file and the transcription. And it has to be thousands of them, thousands. So you can train your model. We have been training for Spanish. I wanted to transcribe a lot of recordings, but I had just only time for 1,000 transcriptions. It's very hard work. And when you are training all your models, you have this output from DeepSpeech. You're telling here what the audio means, the transcription, and it's going to try to understand and train with the neural network what does it mean, that audio, and what does it mean, each word, each letter, and all of that. For example, let's see if there's something. Well, for example, here's some kind of approachment of what we wanted to have. Servicio al cliente pagos, and it says servicio al cliente pago. Well, it's an approach. For a very reduced data set, it's a good thing. So this is not what I want. So the disadvantages is that you have to have a special hardware required to train the computer. You need GPUs, NVIDIA with CUDA. A lot of training is needed. You need, as I said, a lot of recordings. And you need to have a long time and data for do this training. We do this because we have a lot of data. We have a lot of recordings. Well, I don't have a lot of time, but I can put another persons to do this. So the advantages is that you have a fully automated solution. You can automate blacklist databases, and it can be updated automatically. You can block caller IDs linked to associated speech-to-text keywords, and avoid users administrators to update blacklist database, and avoid outdated databases, and avoid relying on third parties to keep it working. So at this point, we're only just talking about blocking numbers, but there's an inflection point that we just realized. We can detect, as we are a PCI compiling company, we have some APIs that tell the recorder that it has to pause and unpause the recording call. But sometimes that API is not called very well. And there are some recordings with credit card information. And we have only a team of 7 people listening to all the recordings in the company. That's like 0.11% of all the recordings that we have that they are listening. So we can detect the credit card data and delete it. We have a tool that is called Sparrow, I'll talk about later. We can do automated call analysis, and that gave us what I'm trying to get in this point. As I told you, we wanted to have insight in all our voice service infrastructure, but we can give to the operations team and the sales team insight about what's going on with the agents, who is selling well, which packages you need to sell. For example, there was a recording that the person wanted a light package for his flight, but the agent was telling, I don't offer that package, I don't offer the package, and there was like 3 minutes of conversation, and it was really, really annoying because you have a contact center to sell, and if you don't sell, well, what's the point of having that contact center? So if we can provide some analysis that this is happening in a lot of calls, we can tell the operation and the sales team, you have to offer these packages because people are calling for these packages. So we can improve technology to prevent misconducts. There are some agents that just only don't work very well. Well, as I was talking with Lawrence of Qmetrics, he told me, why do you hire people if they don't answer calls to sale? There's something bad that you are really, really doing. So we want to give this kind of technology to the operation and the sales team so they have a better customer service to our clients, and we can sell better. So also, there were a lot of talks here. They were focused on how to use Amazon and Google's speech-to-text engine and other products like Lex, Amazon Lex, and all of that. And you can do automated IVRs, or as they call them, call bots. But with this, you can have on-premise solution, and you don't have to connect to a service provider. You have this, and there's no latency on this. So this was the tool that I was talking about you. This takes the audios from Oreca or VoIP monitor. The user just only enters the ID of the call and the recorder system. It gets to a server. You only say which times is that you want to cut. It processes it, and it doesn't download to the computer of the agent. It syncs with the recording box. We are compatible with VoIP monitor and Oreca. And well, I'm going to release that. If you want to follow me on my Twitter, I'm going to tell you when and how I'm going to release that. And well, let's go to the dangerous demo with call speech text with DeepSpeech. Well, that's the ultra dangerous demo. So, okay, I hope this works. Okay, let's see. I'm going to try to translate, as I said, on English first. So let's hear again the recording. I'm going to try to do...
I am sorry, that's not a valid extension. Please try again.
Okay, so I'm going to run this script. Run invalid. No, relax. Yes. Okay, here's the script. We're telling the computer which language models we have, where's our alphabet, at our output graph that has all information of how to process the speech to text. And we're going to provide also the audio, and we're going to put it on a TXT file, and we're going to try to make some keywords of this TXT file. Nope. So we're running this, and let's see what's going to do. It already loaded the module, and now we're going to try to make an inference. This is what it goes and tries to transcribe the audio. So the result is, I'm sorry, that's not a valid extension. Please try again. It's a close approach. It's a pre-trained model, but well, it's something that is working. And you don't have to call Google or Amazon. And it's running on this. The amazing thing about deep speech technology is that they are trying to do implementation with TensorFlow, so you have this technology embedded on your cell phones. So that's going to be an awesome part. And we have some keywords that they were just only mentioned one time on the audio, but you see what I'm going to do. What I'm going to do is store that on a database and have, if I have a multiple occurrence of these words in a database, I can make custom alerts to the operations team, and I can also give the full transcripts. I was also talking with Lorenzo, and he was trying to make on his dashboard of Qmetrics, you have the real-time calls. But DeepSpeech, Mozilla are trying to work with a streamer for this. So we are going to work in a future. So I could provide him the stream and all the data, the transcriptions, so he can put on the Qmetrics dashboard of the call what is the people talking about. It's something that we have to work a lot. So I'm going to run another one. So we have, for example, you have to know this one. Obscene, I think I have. I don't have that one. That's really, really bad. Let's go here. What is that? Remember, this is a dangerous demo. So, yeah. I should have turned off all my notifications. Yeah, all my notifications work and all of that. This, yeah, you should have, I have it. Let's try to
Congratulations! You have successfully installed and executed the Asterisk open source PBX. You have also installed a set of sample sounds and configuration files that should help you to get started. Like a normal PBX, you will navigate this demonstration by dialing digits. If you're using a console channel driver instead of a real...
So let's go and run. Congrats. And let's go. It takes a lot of time. really a lot of time and a lot of processor work. So this is why you need a GPU card or 2 GPU cards, so it can be faster. We can go and check how the processor doing. My bad. Well, it has already. You have successfully installed and executed the Asterisk open source PBX. You have also installed a set of sample sounds and considerations. Well, you have a transcription there, and it's working. And it's a pre-trained model. It's not an official model. The community of Mozilla is working to have better models for all languages. I'm working in the Spanish models for Mexico and Colombia, and we are trying to provide those models public so you can use it. And you have the keywords there, how the words were repeated there. And well, I'm going to do another demo of a call that we have on English. So let's say which one was? Bad call. We have a bad call. Example bad call.
Llamada entrante en 3, 2, 1.
Thank you for calling Royal de Holiday. My name is Nayeli. Can I speak into?
Hi, good afternoon. Look, I just called recently. They put me on hold, and I was on hold for a long time. I don't want to be on hold.
Just one moment, please.
Well, that's 5 minutes. Let's try to run the demo. Which ones is room bad call? And here we go. It's going to take a lot of time. I expect a little time, and we can check how the processor doing. The machine. Sorry, my bad. You can see here how the processor behaving. It's a lot of work. We have a lot of DeepSpeech process. Here, and there. Think you got them by my name. Well, we have to work a lot of because it's how I'm telling you. It doesn't recognize very well some things, and you have to work and train. This is something that like a company of Google and Amazon, they have 1,000 employees, but this is what we are trying to do with the community. So it's almost time to finish. I'm going to skip I'm going to try the ultra dangerous. Yeah, let's see if I can do this. Which one was? Really? Sorry, I hope this, I don't find it. I have a lot of, yeah. Yeah. Which one was? Source. CD, OPT, DeepSpeech, LS. Demo. I show you the file contents so you think that I'm not just fooling you. You have the Spanish mode. No, this is not the. This is not what I wanted to do. Cron Translate. This is the Spanish model, and we're going to try to do a Spanish call. So let's go for Run Translate, and it's going to try to transcribe this audio. Let me see if I have this test file. Dragon? No, it's I just named the project like that. Well, it's running the inference. I hope this doesn't take a lot of time. And well, Danger Demo is not working. Yeah. Can I finish just a little? Yeah. The conclusion. Yeah, thank you. Automating is essential for every business nowadays. You must use AI or ML for practical automation. You don't want to code everything. You must use or contribute to open source like Asterisk. Open source will fit your needs and reduce costs and help others. And future work for me, I have work to do. Train DeepSpeech for Spanish variation, Mexican and Colombian. Use AI for STT in Asterisk. The free PBX were working with something like that. Integrate DeepSpeech as Asterisk third-party module. I want to see that DeepSpeech is part of the Asterisk installation, so you have an STT embedded on your Asterisk. Integrate DeepSpeech Asterisk with my current applications like Aloha and Sparrow, QMetrics, and other ones, and contribute to existing public Blacklists database automatically, and use ML, Mozilla DeepSpeech, and Asterisk as a state-of-the-art alternative for automated calls. So this is something that is already happening that I want to see. The progress with the assistant. Making a phone and schedule a haircut appointment in a good way. You want to have Let's go back to this example. The Google Assistant makes the call seamlessly in the background for you, the appointment for you. Let's listen.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
Well, this is happening right now. Google is implementing it. And I would love to see some Asterisk things doing like this. So it's everything. If you have a question or answer, I think that everyone is going to
Yeah, well, unfortunately, we are a bit tight on time, and it is lunchtime. So perhaps we can take questions over lunch.
Yeah.
And I want to see more of this dangerous, ultra-dangerous demo in the dangerous demos tomorrow.
Okay, thank you.
But even more dangerous.
There are candies and some business cards if you want. There are Mexican candies if you want.
Yeah, next.